So, like I said before, I'm going to be giving the same talk on Thursday afternoon near the very end. However, here we have really cool stuff that we're giving away. There, I don't know if I'm allowed to give away stuff there. So, what I want to talk with you about, though, is kind of where we've been, where we're going, and where we see things going in the future. And I think that's one of the big reasons all of us come to the show, right? Is we want to see what everyone else is doing and what the really new cool stuff is. So, how many of you run your own clusters? So, who are admins? Okay, one admin. Hi. Being an admin is a lot of fun. Okay, who are users? Okay, great. So we mostly have users. So, oh good, this does work. This is kind of how it is. From the very beginning of time, all of us have gone through and we've wanted to build tools that make it better and easier for us to do whatever our jobs are. And we start off with really simple stuff like this, and now, this is what we're shooting for, right? The great big systems. And we're always looking at what's going forward and what's going to happen next. Now with that, I said we're always sitting here looking off in the future. Now one of my favorite bands, which dates me obviously, is Counting Crows. I think Counting Crows is awesome. And in one of their songs they have this line that says, if you've never looked off into the distance, then your life is a shame. Okay, so all of us are looking off in the distance. That's what we're kind of all excited for. Where are we going to get there? Where are the things we have to do? Where are the problems we need to solve in order to make that happen? And instead, what I'm going to do now is I'm going to kind of take us back just a little bit. So here we are, right? 2013, we're all here in Denver, which is awesome. And let's just kind of slide back the time, back. 1966. I'm not going to ask how many people in here were alive in 1966, but I'm going to fair guess, not very many. So there's this book. It's right here. Have any of you ever seen this book before? Okay, this is published in 1966. And I'm going to kind of break with traditional presentation things. They say never read your slides. Okay, I'm not going to read my slides, but I'm going to read this because I think it's important for us to look back and see some things in here. Okay, and this was written by Dr. Douglas Parkhill. And this is the only picture on the internet that I could find of him from a newspaper. Canadian. Okay, and this was not in 1966. But I'm just going to kind of go here at the beginning. I'm going to read just a little bit. And I want you to think about how does what I'm reading in here apply to where we are today, okay? Ready? As generally envisaged, a computer public utility would be a general-purpose public system, simultaneously making available to a multitude of diverse geographically distributed users a wide range of different information processing services and capabilities on an online basis. Obviously written by a professor because the sentence is forever long. As in any utility, the overhead would be shared among all users, with each user's charges varying with the actual time and facilities used in solutions to his problems. Ideally, such a utility would provide each user, whether he needed it, with a private computer capability as powerful as the current technology permitted, but at a small fraction of the cost of an individually owned system. Okay, just remember, 1966. What does that sound like? We'll go back to that in a minute. This is what he said. I want computers to be like utilities. We go out and we say, I flip on the light switch, right? I flip on the light switch and the light comes on. It's always out there, it's always for me. So, is this what he's talking about? Do you think cloud? Is that kind of, I see some of this and I okay, I think cloud's part of it. Okay, but it's not just about cloud. It's about what we're really all trying to do as an industry not just one industry, a whole bunch of different industries. Okay, so I'm going to now do a very big oversimplification as we look at our different industries in here. So we walk around the show floor here. It's great. We have hardware vendors, we have software vendors, we have all of these different people who are doing bioinformatics, physics. Hopefully you're having a chance to see all these things. And they tend to fall into these categories, right? So we have HPC, that's mainly what we're here for. Then we have cloud computing, we have big data, we have visualization, all these different types of computing that people want to have available to, because what they're really trying to do is solve their problems. And so here's my oversimplification, which is probably egregious, but I'm going to say let's just take all these, and for the purpose of the talk today, we're just going to say computing. We're just going to throw them in there. That's pretty egregious, isn't it? Okay, but if we really pull back and look at what Dr. Parkhill is saying, look, we want to be able to provide out the ability to solve our problems with the different computer technologies and software that's there that we can use. Okay, so yeah, here's our center again. Now it's red instead of blue. And we have all these different things, right? Multiple fields of study, interest, things we're trying to solve, multiple different users, different things that they're trying to do. And for our one admin here, he knows that all the users are always coming to him saying, how do I make this work? How do I get it to work? This is what I want to do. Why is my job not running? And the admin's job is a lot of fun. Okay, because don't shake your head like that. They don't know, so just play along, okay? Okay, so this is what we're trying to do. So, one of these ideas that we are seeing kind of happening from our side are these ideas of workflows. The very most simple one, which we're seeing a lot more in the last couple of years here at Supercomputing, is this idea of workflow in terms of computation and visualization, right? So you have your jobs, you put your job in, calculate, 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 then you have another job or a subset or a epilogue that runs that then lets you visualize it. So it's this idea of, we have these multiple stages that we're going to be going through with our workload to try and get out the answers that we really, really want. And now as the industry is continuing to advance and we're having all these other groups coming in, we think this idea of workflow is going to become even more important. Part of that also is, I don't know how many of you have worked with industries that do basically HPC, but they don't call it that. We run into that all the time. Come in, they say, okay, this is what we're doing, and we're like, that's HPC, and they say, no. They have a different set of words for it, but for all intents and purposes, it's HPC. It's all inside this idea of computing. So, for example, here we have this idea, let's say we have cloud. So, a scientist comes in, logs into the system, and it has it build their little desktop environment that they need to work with. And so they start with that, and from that, they do some of the scientific computing stuff. They run their basic, well, they're not basic, but they run their initial things to get their data sets ready to go. Okay, then after that, maybe it becomes some type of a big data problem. So they now say, okay, we're going to take our data set, okay, we're going to run map and reduce on it, or any of the other number of big data problems. We get our answers out of that, which we now are going to feed into HPC. Now that may give us our sweep range for doing our HPC problem. Okay, and from that then is going to go on to visualization so that we can actually see what it is that we have coming out of the system. Okay, so we walk through this workflow, which is now tying together many more types of computing into these workflows, because really this is what we want, right? We have our job needs, and we have the available resources. We want to schedule those for the big main task of answering the question that we're trying to answer. And hopefully not asking why my job isn't running to the admin too much, okay? So that's what we're trying to optimize. And so what we're seeing is that HPC, these things that us as an industry for many, many years have been going through and figuring out how to handle, really has applicability in these other areas because it's all about computing. HPC is the high performance side of it, but all these other things as far as optimizing and putting things together has applications elsewhere as well. So for example, let's talk about topology and those types of areas. Okay, topology scheduling, as Ian mentioned, we have a demo here. Okay, how do we place our jobs out in the cluster so that we have the least amount of network collision traffic as possible? Okay, that's important anytime we have any type of job that is more than one process, right? So anytime we have inter-process communication, that's going to help, whether that's HPC, whether that's big data. Okay, so as an industry, as HPC, we solve that problem, we solve it for a much bigger set. Another one, really big one, especially that a lot of us are running into now, is this idea of data locality. We have customers that have literally petabytes worth of data. And it's like, okay, how do we make sure, again, that our data is where it needs to be, where our jobs need to be in order to run? Whether that job is an HPC job, a scientific computing job, a big data job. Again, it's that same problem. How do we make sure that we have what we need, our resources, our data resources, in place at the time and place we need them? And then, obviously, we're never going to be away from having, the specialized hardware and other things for an HPC cluster. I think we're always going to have that. So I'm not saying, take our HPC spinners and we're going to neuter them and make them play nicely with everything else. All these other types of things are out there. Instead, it's going to be pulling in different types of systems in to interact with our HPC systems in order to do that, because obviously there are some types of hardware that some of our HPC jobs really, really need. And we go throw that on commodity hardware, or we go throw it out in the cloud, that may not work so well for some of our jobs. Other things we have, it's okay. I ran Monte Carlo simulation. It may be perfectly fine for me to throw it out, somewhere else. Okay? So making sure that we've solved these problems. And again, this is one of those problems that HPC has really been working on and we have solved, right? How do we get our jobs where they need to be on the right type of resources for them? Okay? One other merger here of ideas. So here's our workflow again. And we're just going to pull some of these out like so, and we're just going to take HPC and we're going to put HPC and cloud together. Now this is a really, really interesting one, because when the idea of cloud first came out, I was here at this conference, right? And it's kind of like, it was naughty to say anything that was like HPC and VMs or HPC and the cloud. Any of those combinations, using those two words in the same sentence was just kind of a no-no. Okay? Now since then, what we've kind of been finding is that, again, for certain types of workload, doing HPC in the cloud makes real sense. There's a lot of companies out there that are doing things, well, a number of different types of things. So here, this is my silly little cloud. I need something at least, kind of, There we go. How do we define it? So when we say HPC cloud, do we mean we're building an HPC cluster out in the cloud entirely? Does this mean cloud bursting, where we're saying, okay, we're going to take some of our HPC workload and push it out there when we need some extra capacity? Or like this one where we're talking about saying our HPC jobs get encapsulated in these VMs. So I can say, basically, I have a VM that runs such and such a code, start that VM, it starts up, runs the code, shuts itself down, and closes down. Which is it? And the answer is really kind of all of them, because we have people who are saying, we want any one of these. Okay, so again, we're seeing these merging of these technologies for the problems where they make sense. And there are certainly problems out there where it does make sense to run an entire HPC cluster out in the cloud. There's a company that's doing it that's had some great success with that for problems where the people only need a 10,000 node cluster once a year for like 8 hours. Okay? Cloud bursting, whether to public clouds or private clouds, again, certain types of codes require that. So, really what it comes down to is, it depends on how we want to define cloud, because it's really all of them. Now we're going to take just a short break here. We're almost done, so we can get to giving away the swag, because I know that's what everyone's excited for, right? And this headset's way too small for my head, which is well for whatever reason that you might want to choose. All right, so back to this. Basic idea, we have, again, all these different industries. We're all together, we're all producing different types of things, but we're all related, okay? Different types of problems, different types of computing technologies. And with that, what we're really finding is that a lot of our HPC things provide this base. So obviously we're a company that does scheduling. So we do scheduling and meta scheduling. So some of the forward-looking things from our point of view is that really these workflows, these ideas of these different types of jobs, different types of codes and problems that we're trying to solve are going to become more and more part of our day-to-day HPC center type experience. And that's going to happen for a number of different reasons. Partially because our admin here, who likes all of his users, nod, who likes all of his users, wants to provide as many different things to the users to enable them to do their jobs, okay? And so, like we've already talked about, seen happening with the HPC compute followed by the visualization, we'll see more and more of that, okay? I think we're also going to see more and more of these industries start to recognize their external HP, that they really are HPC type workloads. And by working together with our groups, will enable them also to provide more solutions. So I think we have a really, really exciting, exciting future. So we're going to go back to the book one more time. I'm going to read one more section from the conclusion because I think it's very, very telling. And I think it's important for us also to, remember where we've come from on this stuff and the visions that are going forward. So here we go. This is in the very end of the conclusion. It is the writer's hope that out of the discussions in this book, a clear picture of the computer utility has appeared. In this picture, the computer utility constitutes neither an ostentatious term for a superior sort of service bureau, nor yet a fanciful excursion into the realm of science fiction. Instead, it represents a natural extension of familiar technology in such a way as to create a revolution in the distribution and utilization of computer power. A revolution that promises ultimately to make that power as freely available as the telephone service of today. Out of this availability will flow social changes and opportunities for human development that promise to make the last decades of the 20th century among the most critical that the human species has had to face during its million-odd years of existence. The present state of the computer art is advanced enough to permit the immediate construction of many extremely useful types of computer utility, but the full exploitation of the concept will obviously require major advances in the entire field of computer technology. And what I'd like to put forward to you is that we're now at the point where we're going to be able to start really fulfilling this vision that was put forward nearly a half century ago. So by all means, come join us on the journey, and we have great things in front of us. So thank you very much.